Hey everyone, we're going to talk to you today about MIS and your career. In particular, we're going to be looking at a lot of the basic questions of why this subject should even be important to you as business majors. So try to keep that in mind throughout our discussion here. So the major questions that the book outlines in chapter one are: number one, why is Introduction to MIS an important class for business majors? Number two, what is an information system? Three, what is management information systems? Four, what is the difference between information technology and information systems? And five, what is your role in IS security? And basically, the fifth one is really going to be an application of the previous question, number four, so that you get a sense of where you fit into this whole picture. So let's start with why study management information systems. So I'm just going to jump through this here. All right. In in the late 90s, Bill Gates wrote a book, and I'm guessing he actually had a ghostwriter to help him with this. But there was a book called Business at the Speed of Thought that he published under his name. Now, in that book, I mean, he writes about a lot of really interesting things. I mean, obviously, this guy created Microsoft and was able to make just a phenomenal company. Um, what was his thoughts on business and IT? And there was a very interesting part in here, and I don't know if he's the one who originally coined this term, but I remember getting this concept from there. That in this book, he just called information technology as essentially the digital nervous system of a business. Now, I want you to think about that a little bit. So, what does it mean to be a nervous system, right? We all have nervous systems. We all have these nerves running throughout our body that transport signals from throughout everywhere throughout our body. You know, if you get pricked in the finger, you're going to feel that. It sends a signal directly up to your brain, and you go, "Ouch!" You know, you feel that, and then it sends a signal back to your arm saying, "Move it away from that thing that hurt." Likewise, if you see things, you can react to it. If you hear, smell, taste, all the your senses, um, and then we have this massive processing unit called our brain that can do incredibly complex thinking skills. So when Bill Gates described information technology as the digital nervous system of a business, he was essentially saying, you think of all this technology, information technology that businesses have. It essentially accomplishes the same purpose that the human nervous system does. It gives you the ability to send signals throughout the body, um, just like a digital nervous system sends information throughout the organization. Now in the very near future, a lot of you will be graduating and going out into the business world, right? Well, you're essentially going to be the people immersed within the business, working both with this technology and helping to design this technology. And that's what probably where the major difference is between this analogy goes. Um, but consider just the fact that you'll be working with this. It's kind of like a doctor, right? A doctor, it doesn't matter what kind of doctor you are. You could be a foot doctor or a heart doctor, um, a skin doctor. All these doctors have to understand the basic way that the nervous system interacts with their particular part of the body. A foot doctor still needs to understand the nervous system. The skin doctor has to understand the nervous system. An eye doctor has to understand the nervous system. Every single doctor out there has to understand the basics of how the nervous system works and how their particular parts of the body interact with the nervous system. Now, there's even doctors that specialize in the nervous system itself, neuroscientists or whatever, or brain surgeons. That would be very much like the IT people today, right? These people know the technology, know how information works within it. However, even regular doctors have to understand how the basics of basics of the nervous system, right? Well, the same thing goes for you and your career. you're going to be kind of like the doctor is for the body, you're going to be a doctor for the business, right? You're going to have to help a business flourish, to be the best that it can be. In order for you to do that, you have to understand how the information technologies and information systems work, and how you can use them and how you can help design better ones for your business. And that's what I really want you guys to get a clear understanding of in your career. It doesn't matter if you're going into marketing, accounting, finance, management, supply, maybe a specific kind of management, supply chain management or human resources or project management. The fact of the matter remains, you're going to have to know how to use information systems, but more so, you're going to need to be able to design new systems or help IT people design new systems, work in collaboration with them to make a more effective system so that your business is going to flourish. It's going to be freaking awesome, right? And you can't do that if you don't understand how this technology works or how systems work. So a big part of why you should study MIS. Now the book says this should be the most important class that you study. It's a little bit of a hyperbole. I wouldn't say it's the most important class, but it's absolutely an essential class that you have to study if you want to be a um, great at the career that you choose. And to that end, we're going to help you to understand how information systems facilitate access to information that you need. And so that's a big part of this, is understanding how do you get the information that you need so that you can make better decisions. And the better decisions that you make, the better your career, the better your interaction with the business is going to be. It'll also give you the terminology, this class will give you the terminology necessary to interact with your company's IT staff. Because a lot of times you're going to be working with IT people. If you don't understand what the heck they're talking about, you can't collaborate with them. And you have IT people who don't know the business. And so if you don't know the IT and the IT people don't really know the business, how can they create systems using technology that really meets your needs? The fact of the matter is they can't. So, you want to do well in your career? Study this stuff, right? I'm not saying you have to go out and be an MIS major. Although I think it's a great career. Obviously, I chose it because I love technology and I love business and understanding the processes and how we can really solve these problems that businesses have using information. In fact, I'm of the opinion that everything essentially is going to become information, especially if you look at 3D printing market, and maybe we'll get to that later in the semester. But essentially, even physical products now are going to be turned into information. So what's left? I mean, the only thing you have left to really to talk about is information and perhaps the energy to convert raw materials into a finished product, and the rest of it's going to be all done by technology. So there's going to come a point in the future, this may be 20, 30, 40 years down the road, but we're already seeing the process starting now. And the question is, do you want to be the person at the forefront of that or the person who's lagging behind and just kind of, well, I guess I should learn this because everyone else is? Or do you want to be the person who's going, man, this stuff is freaking awesome technology and I see some great potential for our business. Let me show you how. And if you can do that by understanding the technology, understanding where these systems are going, and be able to be someone who advocates for more advanced usage of these systems, your career will be freaking awesome. So as you'll see, IS is a highly rewarding career choice in and of itself. And like I said, I love it. I think it's an amazing career. And that's why I went into it to begin with. I'm not going to try to convince you that you have to change your major, but if you do change your major, this is a freaking awesome one to change it to. But even if you don't go, even if you decide to go into a different business field, you're going to have the IT skills to give you that leg up over the competition, because there's going to be a lot of people graduating from a lot of schools at the same time you are, right? So what's going to set you apart? What's going to make you competitive? Now, it doesn't matter if you're marketing, accounting, finance, management. Having a solid foundation in technology can help you. Just the skills of working with things, like in marketing. It can be something as simple as web development to understanding social media or even data mining. And data mining goes beyond just marketing. You can also include that in accounting and finance. Um, but even in accounting and finance, you want to know more stuff like access to data, the raw data, so you can really understand where the numbers are coming from and where they're going to. You also might need to create models to project where we're going to be long term. To create these models, you need data to create it. And then on the management side of things, you need to understand organization and how do people communicate and collaborate throughout the organization. How do you create a virtual team that's absolutely phenomenal? Because let's face it, a lot of businesses today are finding that travel is very expensive, technology is very cheap comparatively, that we can create great virtual communication across continents. How do you manage that well? So if you understand the technology, you can help facilitate that. There's even technology that is being used in strategic development and understanding the knowledge of what resources you have that can give you a competitive advantage. That's what SEA stands for, strategic competitive advantage. Because by understanding, in fact, information in and of itself, knowledge in and of itself becomes a strategic competitive advantage. Because guess what? You're the only company that has that information in your own databases. Now, other companies may have their own information in their own databases, but you're the only one that has your information in your database. And that is a competitive advantage because there's so much you can do with that information. Now, over the past 20 years, what we have seen is an explosion in growth in information systems and computer systems, particularly job related. Now, only one out of two recent graduates are either unemployed or underemployed, but not in all job categories, right? If you have some degrees like creative writing or maybe European history, it's a lot harder to find those jobs. That's not true in information systems. In fact, a lot of our graduates from our program have already gotten jobs. In fact, a lot of them get jobs 6 months prior to graduating. Right? And they're getting good jobs. I think our average salary is roughly around $51,000 a year. Not too shabby, right? So if you do have any inclination, you do like some technology but not sure you want to go into it, or even if you want to stick with marketing, it's not a bad idea to consider a double major in MIS, in part because just look at the jobs that are out there, man. The fact of the matter is, computer systems and information systems will continue to be a dominant force in every organization going forward. So what's going on here? All right, so we're currently in what's called the information age, and this started in 1950. It's a time when information drives the economy. Why 1950? Well, 1950 kind of signals the begin of the computer age. There were some early versions of the computer system. So if you listen to my prior supplemental lecture in a brief history, you'll see in the 1940s a lot of the early versions of the computing systems were developed. By 1950, though, it was well defined that we had computers. It was also the date when we had more white-collar workers than blue-collar workers. And that is a major change. right? So blue collar basically meaning the people who worked in factories or farms, people who worked with their hands. White collar workers were people that worked with information. They worked behind desks. These could be as simple as clerks, um, people who did a lot of worked with, data came in, they had to process it, doing some calculations or maybe just inputting things into different systems. Or it could be someone more complex like lawyers or engineers. But in 1950 was the first year that there were more white collar workers than blue collar workers. And now today, that number is dramatically more. All right. So the knowledge workers of today outnumber all others by at least a 4-to-1 margin. So why has that occurred? Why is it that information, these knowledge workers are used and so incredibly much within organizations? And the fact of the matter is that information has value. Knowledge has value, a tremendous amount of value. And that knowledge workers can take this information and create new value. So in the old world economy, you create a value. You created value with physical things. You create steel and you shape it into some product, and then you ship it out, and then you can build rails or pots and pans or cars. And yes, those things were of value. But in the information age, you take information, you change it, manipulate it, process it, model it, and you create even greater amounts of value. So yes, you can still take and create a car, but the information that's inputted, that's required to create these high-end sophisticated engines and electronic systems within cars and processing systems within cars, it takes an incredible amount of information and an incredible usage of knowledge workers who are processing this information to make really incredible products. In fact, today we have something called telecommuters. Now, these have been around for the last 20 years. It's not that incredibly new, but we're finding more and more and more people can now do what's called telecommuting, which means they don't even need to go to their office. So what's a telecommuter? All of you, go stand up, go look in the mirror. You are, right now, listening to this lecture. You are a telecommuter. You are working at a distance. You don't have to go to the classroom to hear this lecture. In fact, I'm sitting at home right now making this lecture. So I don't even need to go to my office to do this. So we're all telecommuters, and yet we're all knowledge workers, right? I'm creating the knowledge in form of this online lecture. You're consuming the knowledge, but hopefully you're applying this to your own personal situation and adding this knowledge to your own context. So let's take a minute and talk about the opening vignette in chapter 1 about this lady named Jennifer who was getting fired, right? So she's a new graduate. She goes to work at this firm. 6 months later, they decide it just isn't working out, right? Why is this? Well, Jennifer, uh, why was she let go? Well, I mean, from the dialogue, it seems that Jennifer is expecting to be a college student still, right? She wants specific instructions. This is what you got to do. This, and this. I do those things, check off lists, and then I'm done. But that is not what businesses want nowadays, okay? In fact, that's why I'm moving further and further away from getting students specific instructions. And I think other professors are doing this too. And that can be frustrating for college students because that's what they've grown up with. And probably some of you felt this, where a professor will come to you and say, this is what you need to do. And you're like, well, give me more details. And you're like, well, you're supposed to figure out those details. You're like, well, why? I don't understand. I need to know specific details. What do I need to do to get an A? Well, in business world, there is no A's or B's or C's or D's or F's, right? There's only come up with good, do some solid thinking to come up with better processes so that we can have a more competitive business. So to do that, you really need to develop your ability to think, to be able to work, right? And you need to be able to get confidence in yourself and what you do. You need to be able to start looking and taking the initiative and being creative. And if you feel like you're missing these things, well, it's time to start practicing them. And so the more open-ended things that you start working on, the more confidence you'll build in yourself, the more knowledge you have, the more you're able to create new things. Um, and hopefully you'll start wanting to take initiative when you go out there. All right, so let's break this down. Why did Jennifer lose her job? There's really four major things that businesses are looking for that Jennifer did not apply in her new job. One, she needs to have the ability for abstract reasoning. You need to be able to pull away from just looking at the specifics, the details. It's very easy to go in and say, okay, I see this is how your business process currently works. These are the specifics. Okay? It goes from Bob to Joe to Fred, and then it goes, and then it gets shipped, right? So yeah, that's fine. You do have to understand the specifics, but then you need to be able to step back and say, all right, how can we model this in a way that new people coming into an organization can work with it, right? So make models, representations of seeing the entire process from a big picture. First it goes to sales, then it goes to accounting, then it goes to shipping. Might be a process at a more abstract level. Then it goes from Bob to George to Fred. You also need to be able to start thinking in terms of systems. So in a system, and we'll talk a lot more about this here in a minute, but there's a lot of different components that are interacting with each other, inputs, outputs, processes that are going on. You need to be able to think of the entire system and not just look at the components individually, because this can lead to a lot of problems when you're working trying to solve a problem. You might notice that a certain method is not working, but which one of the components is the problem? Well, it may not be one specific component, but how the components are constructed together that is causing the problem. So you got to be able to think of the entire system as a whole, not just at looking at individual components. You need to be able to have good collaboration skills, okay? The willingness to work with others with your work and to get good feedback. And a lot of times, in order to get good feedback in an organization, you're going to need information technology to make that happen quickly and easily. All right. In fact, we're going to spend the next 2 days talking just about collaboration, in particular collaboration in projects for students. That's how important we think this is for you guys. And then lastly, you need to be able to have the confidence to experiment, to try things, not to have this fear of failure. Because yes, you're going to fail at some things, and that's okay. Now, you're probably thinking, well, in classes, no, I can't fail. I got to get an A. I got to get an A. I got to get an A. But that's a different mentality than what is needed out in the business world. There's going to be so many new things coming out, new technologies. Innovation is going to continue at a fast and furious pace. And so there's going to be all these new technologies. And you're not going to always be able to figure out which technology is best for your business. So you're going to have to be willing to try things. But what you also need to be willing to do is when you try them, realize that some of these are going to fail, but to be able to identify when they're a failure and when to move on. So that's part of understanding that ability to experiment. Now these 4 skills are all very fundamental to how businesses are starting to function. So it's important that you develop these, and this class is designed to help you with these 4 skills. In fact, the abstract reasoning part, we have 4 chapters in here, and specifically that we're going to be looking at. How to model looking at the model of information system in Chapter 1, what we're talking about today. Chapter 2, how to use the IS model to assess scope of any new information systems project. Chapter 5, how to create data models. Chapter 7, how to make process models. So we want you to be able to start thinking in more abstract terms. We're also going to focus a lot on systems thinking. So the ability to model system components, connect inputs and outputs among the components to reflect structure and dynamics of systems observed. And this is being done in every chapter, including this one, but especially in 2 through 7 and in Chapter 10. The collaboration we're going to look at, like I said, in the chapter extensions, which are actually, it should say extensions 1 and 2. But a collaboration is any activity of 2 or more people working together to achieve a common goal, result, or work product. And there are best practices out there on how to do this. So we're going to try to help you know how to use this, but also help you to develop your skills with collaboration using technology. And because it can be such a great tool for improving the collaboration abilities. And lastly, we want you to experiment more. So make reason analysis of any opportunity. So in experimentation, it's not that you just try things randomly. You actually try to look at something. And so you might say, all right, I think our business needs some sort of social media presence, but which social media platform is best for our business? And so you might take a look at LinkedIn or Facebook or Twitter or Google Plus and say, all right, which one of these 4 is best for our business? You look at you look at best practices for each of these, and you say, all right, we're going to try one. Let's go with LinkedIn. But these are our metrics to judge if it's a success or not. And if we don't reach this metric, we're going to kill it and maybe try another one. Alternatively, what you might do is say, we're going to try all 4 of these at the same time. After 6 months of doing all these and doing a similar series of promotions on each of these, we're going to evaluate which one produced the best results for our company, and we're going to kill the other 3, or analyze which ones to kill at that time. All right? So being able to experiment is realizing, okay, we're going to try some new technologies. Some are going to work, some may not, but you got to think through the process, come up with a good plan to assess what we should do if things don't work out. Requires a lot of critical thinking, thoughtful analysis, and acting fast, because there's going to be a lot of new opportunities coming up throughout your career. So let's stop for a minute here and talk about what is management information systems, because that's the name of this class, right? Intro to Management Information Systems. So you better understand at least what the heck we're even talking about. So management information system is the process of managing and using information systems that help businesses achieve their strategies. So there's 3 parts to this: management and even using. Okay. There's the strategies, and there's the information systems themselves. So let's look at each one of those. Management. In this context, we're talking about develop, maintain, and adapt. This means that we can recognize that information is a resource that has value. Now, some information has a very minuscule value, almost 0 value, and other information has a tremendous amount of value. And sometimes it's only information when it's combined together in certain patterns that has great amount of value. But the management part of this is saying, all right, we need to develop, maintain, and adapt this information. So we develop information systems to make information resources exploitable, meaning we have this value in information. Now, some of this information, we don't know it's of value yet because we haven't even seen its potential. And as we continue to gather more and more and more information, in fact, if you look at our data that's being stored, so these data warehouses, and you might hear these terms thrown around, or data centers, where lots and lots of data is being stored, and it's estimated to be doubling every 2 years the amount of data. I mean, if you think about how much information that is, it really kind of blows your mind. The part of the problem is we're storing vast quantities of information. Oh, so let me rephrase that. We're storing vast quantities of data, but we can't turn it into useful information without we can't exploit it because we don't know what's even there or what the potential correlations between that data could be. And so there's now new careers being developed around what's called business intelligence or business analytics. Some big terms that are being thrown out there, and there's actually new programs being developed, including here at ECU. We're developing a graduate certificate in business analytics because we know of all this data that's exploding, and all we're storage of, again, the storage of data is doubling every 2 years. But we have to be able to pull out meaningful information out of all this data, right? So the management of this is phenomenal. All right, we also need to create information systems that meets your needs. So you want to take an active role in the systems development. Why? Because business professionals like yourself understand the business needs and requirements. IT people don't. And trust me, I've worked in IT to know this, right? I've worked with IT people who really don't understand the business process. The only reason, there may be phenomenal programmers, phenomenal people working on networks and database administration. They know the technology 10 times better than I do, but they don't understand the business needs well enough to create products without your input. And so if you don't give them that input, you don't get something back that does what you need. And a lot of really bad software has come from this. I mean, there's lots and lots of stories, and maybe I'll share a few of them with you this semester, about businesses that created products that don't do what's necessary for the business people. And so even though they spent a lot of money creating this information system, it didn't work. It didn't do the job that was needed to get done. All right, so there's also the strategies part. So achieving your strategies. While it's tempting to pursue the tech just for the sake of the technology, IS investments are typically long-term. They're a resource-intensive decision, and a lot of money's put into these, and you may spend millions of dollars in businesses to buy information technology. But if it's not tied to strategic objectives, it's wasted money. So MIS empowers users to achieve business objectives, their strategies, the long-term view. They exist to assist business people, and information systems exist to help achieve business goals and objectives. It's a very fundamental part of information systems, and that is why many businesses have a chief information officer, is because they would need somebody at the executive level who can work with the strategies of the business and help guide the investments in information technology so that they're in alignment with the business strategies. So what exactly is an information system? Well, if you think about systems in general, they're a group of components that interact to achieve some purpose, right? So there's various natural systems like your solar system. We talked about the nervous system, right? You can also have things like manufacturing systems or economic systems. There's a lot of different components interacting, but they're all moving and achieving some purpose. And it may not be a conscious purpose, but to some end, right? So if that's a general definition of a system, an information system is also a group of components. And we'll talk about, there's actually 5 different components we'll talk about that interact to produce And I don't really even like the term produce, but that's what the book uses. I would say to manage and produce information, because it's not just producing new information, but it's also managing information, collecting information, storing it, securing it. There's a whole process in there. Now, this is a very important part of the definition. It may or may not be computer based. Information systems. You can have a complete information system that does not use any advanced technology. You can have an information system that is like what we do at our house. We have a calendar on the wall. That's an information system. My wife and I interact. We're part of the people. Whenever we have a new event that comes up, our procedure is to write it on the calendar on the wall. So you could say we have hardware, which is the calendar. Don't really have software. The data is the actual event itself. Procedures to write the event on there, and the people that do it, me and my wife. Right? And that's a system that we've developed to keep track of what's going on in our family. And it works pretty well. Right? It doesn't require any technology to do it, but it's still an information system. Now, could we do that with technology? Well, yeah, we could, but it'd also be much more expensive than buying a $2 calendar, hanging on our wall, and writing things with a pencil. Right? So you don't always have to use technology to get the job done. So information system is a group of components that interact to produce information. It includes all relevant entities, the people, the data, the processes, and the tools. And the tools, in particular, are what information technology is all about. Information technology are the tools that are used to work with information. It includes the hardware, the software, and the data. So your physical computing system, or your smartphone, or your mainframe, or your printer, your keyboard, your mouse, your router, all of these are just hardware. In order for them to communicate with each other, they need software. So software is a set of instructions, essentially, for what it should do. The hardware is the physical components. The software is the set of instructions that guide it and tell it how to interact with each other. And now software has actually got many different levels of software, from things such as firmware and operating system, all the way up to actually applications, which if you have on a smartphone or tablet could be called apps. That's an application. But it's a piece of software that works on top of the operating system. And it requires, it also includes the data. Right? Those are the IT components. Information systems includes all these IT components, but adds the interaction with people and procedures. So how do people interact with the components, the actual IT? Do they input the information directly into the system? Who does that? When do they do it? Is it immediate? Is it delayed? Is there doing it in batch or ad hoc? A lot of different ways of doing things. So what is your role? So let's take an example of this, of an information system, by looking at security. Now, security is important, obviously, and we'll talk again more about this later in the semester. Security is very, very important for a business. So let's look at this. So 5 components. So we have hardware that can help with security. If I talk to you about my router at home, I have a router and a modem that allows me to get internet access. Well, on that, there is security built into it, including something called a firewall, which is actually software based. But you can also have that integrated with the hardware such that you can block certain ports so there's different ways you can interact with the internet, and they're done through ports. I won't go on to the nitty-gritty details, but this is a hardware solution for security, right? And it prohibits certain data from getting through my network. So only some data can get through and not others. This is hopefully to prevent hackers from breaking into my system. But it also includes people, and ultimately it depends on my behavior as a user to have that security work. So for example, I could, I have this great hardware on my desk, and I can have great hardware on my software, or great um, security built into my software. But if I now go to a website, some unknown website, download a piece of software that has no security, that has no validation of trustworthiness built into it, I may inadvertently download some virus or some malware or some vicious piece of program that can take over my entire computer. It could do some very vicious things on my computer or be used to do vicious things on other computers. And all because of my behavior, which was, even though the system of the computer itself had a lot of security built into it, the way I worked was not a good idea. You also have to consider if security procedures are not followed, then hardware, software, and data components of the security system are wasted expense. Another example of this might be a laptop. You can have great security. The IT people could create great security on the laptop, but you take this laptop home, and then you take it to a coffee shop, and as you're at the coffee shop, you're on their Wi-Fi network. Well, the problem with the Wi-Fi networks at the coffee shop is that they're not secure. So even though you think you're working securely, people at the coffee shop, if there's anyone savvy enough, could see the information you're sending. Or worse, someone could steal your laptop. So even though you have a lot of security built onto your laptop, when it's physically in a position where it's supposed to be, if it gets stolen, it doesn't really matter. All that expense was wasted. All right? So security does include all these 5 components: the hardware, software, data, but also procedures and the people and their behaviors. So hopefully we have answered these 5 questions from the beginning. Why is Introduction to Information Systems an important class for business students? And hope you realize that it is absolutely instrumental for you to do well in your career, to have a good grasp of information systems. 2, what is information systems? Right? So the information system is a set of components that interact to manage and produce information. And management information systems is, how do we use these information systems for business goals and objectives, particularly even long-term goals and objectives or strategies. What is the difference between information technology and information systems? Well, the information system includes all 5 components: hardware, software, data, procedures, and people. The technology only includes the first 3: hardware, software, and data. And so we want you to start thinking in terms of systems, because it is far more advantageous, as you saw with when we talked about our IS security and the 5 components. So it's not just about putting certain technology solutions onto a computer, but it's also about understanding your procedures and how you interact with the technology. So it includes the procedures and the people part as much as anything else. All right, so that's the coverage of the core concepts in this chapter. Now, actually, I'm thankful a little bit to Dr. Ferner, who actually developed some supplemental stuff that he added to the end of this. But he wanted to talk a little bit about things such as Moore's Law, which is it is an important concept for you to at least grasp what this is and what it means for the future of information systems. So back in the late 1960s, Gordon Moore, who was the CEO of Intel, made an important observation which he turned into a prediction. So it started with an observation that the number of transistors per square inch on an integrated chip doubles every 18 months. And actually, I think he started at 2 years and changed it to 18 months. There was some wiggle room in there. The number of transistors per square inch on an integrated chip doubles every 18 months. That was his observation. And then he said, I predict that it's going to continue at this pace into the future. Now, up till today, so this is the late 1960s, a long time ago. Today, his prediction has continued at the same furious pace. And it's a part a self-fulfilling prophecy. The people at Intel and other microchip developers made this a goal whenever they were developing their chips, that they wanted to try to achieve a doubling every 18 months. And they have been able to do it. They keep figuring out new ways to continue to shrink the size of a transistor and to cram more and more and more transistors on each chip. Now, this doesn't mean necessarily that we've doubled our speed every 18 months. And sometimes there's a mistaken understanding of that. But what it has meant is as we cram more and more transistors onto a chip, that the price for performance has continued to drop dramatically. How dramatically? Well, in the 1980s, for a microchip to have 100,000 transistors, it cost nearly $4,000 for 100,000 transistors. Today, it is 1/10 of a cent. So that, talk about deflation. And so this is a brilliant example of deflation. If you guys never heard of, everyone hears about inflation. This is deflation, right? The price keeps dropping dramatically year after year after year after year. And that's because a lot of really brilliant scientists and engineers keep developing better ways, cheaper ways, more compact ways to send this stuff in here. It's gotten to the point now where we don't even care how fast your computer, is, because when I go out and buy a new computer, now I'm looking more at what functionality it has versus the actual speed itself, because it's gotten so freaking fast. And it's really kind of revolutionized. It's allowed, and there is some physical limitations to this ratio, in that eventually the transistors are going to get down to the size of atoms, and you really can't get smaller than atoms. But there may be ability. Right now, everything's being done on a two-dimensional plane. There may be a potential to go to three-dimensional planes, which could add a significant leap forward. Now that we don't know, I don't know from an engineering standpoint how easy or feasible that is. But as of now, it's just amazing how much data they can, or how much processing power they can put on these little bitty chips. And that is why you can have a smartphone today that is far more powerful than the mainframe computers of the 1970s. That's right, that little thing you have in a pocket is more powerful than the computers they had in the 1970s, the biggest, mightiest mainframes of the 1970s. We have that power in our pocket. Imagine where we're going to be in another 40 years, and another 40 years of development of this technology. The massive computers they have now, the supercomputers they have now, will you have those in your pocket? Think what that's going to mean for the future. Okay, so if that doesn't give you at least a little bit of thought too, let's consider your job functions, right? What IT skills are needed for each of your various job functions. So in accounting, one of the main things you need to know how to understand how to use is an accounting information system. And almost all of these are computerized, and they pull from operational databases. In other words, ongoing operation databases. So if you can understand database management and database design, this can greatly facilitate your ability to do accounting. Right? So you understand financial information that's needed for accounting is easier to access if it's stored in a database. And if you can design databases, you can pull information out, create your own databases, and do very specialized analyses, looking at where your money is coming from, where your assets are going, producing, which ones are not. it gives you much greater capabilities than if you just simply go with whatever the package you're working with tells you it has. You also can work with spreadsheet modeling for extensive analysis of financial transactions and projections, making calculations, etc. And information security of both your information and financial assets. You have to understand these things very, very well as an accountant if you want to do well in your career. In finance, similar, you need to understand spreadsheet modeling for so any advanced knowledge here, doing calculations or forecasting, understanding statistical packages, whether this is SAS or SPSS, for measuring the risk inherent in a project per se. Again, database management can be very good to understand. So all finance information is stored in a database. And being able to understand how it's stored and in what manner can help you to pull it out in a much more efficient way to analyze it to make better decisions. You also have to understand how financial software works. So you can connect with financial marketplaces to pull the information that you need when you need it. In marketing, you need to understand how to use customer relationship management because marketing is the primary interface to a customer. And so it's important to, if you have your interface with this customer, you have software that allows you to develop that relationship in a meaningful way. And there's a lot of great pieces of software out there that allow you to do that. But also in marketing, you need to know how to calculate your budgets, how to analyze, if you have various different options for marketing, how do you judge which option is going to be best? Having an understanding of how, the various impacts can occur. Well, you have software that can help you judge which impact. So should you do an advertising campaign or should you do an event? Should you go to a conference to market or should you create a social media site? These are all very important. Judging where best to put your money for marketing is essential. Understanding a data warehouse and data mining tools so you can aggregate and analyze large amounts of information, particularly about your customers and their buying habits. Right? In fact, there was a very interesting case study done about at a grocery store that this was the data mining project. So they started looking at shopping habits of their customers, and they found a high correlation between people that put diapers and beer in their shopping carts on Thursdays. Now, diapers and beers, you would first think, well, what relationship do they have with each other? Why are they there's a high correlation between that? It doesn't make any sense. But people started thinking, I was like, well, wait a minute. Maybe they're doing this to stock up for the weekend. Maybe that people that go shopping on Thursdays tend to buy both of these together because that's what they're doing. They're stocking up. Well, what that gives you as a business, though, is as a strategy for helping your customers. So maybe you do a special promotion on Thursdays to give a discount on diapers. That brings them in, saves them money, but then usually while they're in there, they're also going to be buying beer and other things to stock up for the weekend, which is good for the business. But you can also use more advanced things like artificial intelligence for creating business intelligence and by sifting through this tons and tons and tons of transaction data. Also in marketing, you need great communication software for all different types of communication. You need great desktop publishing software for developing high quality ad copies. You need to understand website design, and now even more and more social media and mobile media. Knowing how these technologies work and will greatly enhance your ability to be successful in that type of career. In management, again, database management integration, as well as all types of business information are stored in databases. Understanding how the internet and web portals work for finding and accessing the information that you need to make decisions, management decisions. Knowing how to use spreadsheets for organizing work, calculating value, developing graphs and charts, and comparing costs. Knowing how to use enterprise resource planning software for communicating and sharing information corporate-wide. And we're going to spend a significant amount of time just talking about ERP systems. Decision support systems. So this allows you to pull together information to make better decisions. This is software specifically designed to help you make better decisions. Understanding how electronic commerce works, both business to business commerce and business to consumer commerce. And even project management. There's specialized software to help you with your project management for ensuring that the right resources are in the right place, being accomplished by the right people on time. Well, that's it for today. I'll leave this slide up here for my class, but um, you can read through it at your leisure. But that essentially captures all the important elements of why information systems is important for you and your career, and why studying management information systems is important for you and your career. Hopefully this will get you at least a little bit excited about this course. Please take some time to read through the book and to ask me any questions in the discussion forum, and I look forward to your feedback. Thank you and have a great day.